Now, okay, so this was an example of classification trees. Now regression. Now we'll talk about regression tree. But do you know why? What is the difference between classification trees and regression trees? Can anybody tell me? I think you all know what is the difference between classification, regression, and all those things. Right. Right. Continuous. Right. Exactly. So you see, I mean, this is the main difference between classification trees and regression trees. So here you have, like, if you see, the output is the y parameter is 1 or 0, right? Binary. That is discrete. Even if you have like other values also, you can do it using classification trees. But regression trees are where you have, you know, continuous values. Right? So for example, uh, yeah, I just give this example and I'll tell you like how to solve this. And basically, it is similar to classification trees, just we have some different parameters and so on. Okay. So here, this is an example of drug dosage. On the bottom, on the x-axis, you see this is the drug dosage of in milligram, let's say. So if you give a 10 milligram dosage to a person, the drug is this much effective. On the y-axis, you have effectiveness. So if you give a, let's say, 20 milligram dosage, the drug is 100% effective. Like it will effectively work, 100% effectively work. Whereas if you give like very high dosage, your drug will not work effectively. So you see, like for low dosage and for very high dosage, the drug is not working well. But for medium dosage, the drug is working well, right? So now, how would you decide for what dosage, the drug will be how much effective, right? So let's say if you have taken like 10 or let's say uh, 15 milligram of the drug, how much effective will your drug be, right? So what you do is, again, you start with the root node and go into the subsequent nodes, and you see if let's say dosage is less than 14.5, if yes, then it will go into this node. And in this node, so dosage is 14.5 is indicated by this red line. Okay, so all these values on this left hand side is representing the samples in this node on the left hand node. And how do we determine this is for 4.2% effective? How do we get this number? It is basically the average effectiveness of all these samples. So let's say this sample is 0% effective. This is 0, 0, 0. This is, let's say, 5% effective. This is, let's say, 20% effective. So if you average all these, for six samples, and you will get this 4.2% effective value, right? So unlike, classification trees, this is another difference. In classification trees, if you end up with, let's say, all ones in this node, you will classify that, okay, this is the node where all is, I mean, the y value is 1, right? But in this case, there is no 1 or 0, right? This is not a binary thing. This is not a discrete thing, as Neil Yogi mentioned, right? That this is a regression tree where you will have continuous data. So in this node, you will take the average of all the samples, and you will get the number of how much effective this node is, and so on. You can do so other cuts as well based on, let's say, if it's not less than 45, then it will go into this cut, and then again it will get cut at 29. This is the black line that represents, and so on. Like in any of the nodes, the effectiveness will be determined by the average of uh, um, you know the samples in that node, average of y values of the samples in that. Okay, so is there any question?